This is the sixth in a series of modules about productive tutoring techniques. You, the viewer, will have an opportunity to see actual tutors handling real tutoring situations. These scenes will benefit you the most if you take time to think about and discuss what you see. Throughout this module, this screen will appear as a prompt for reflection and discussion. Questioning has two major functions in tutoring: diagnosis and teaching. Usually, students do not or cannot explain exactly what they know and don't know, so tutors ask questions to locate the source of the confusion. Tutors may also use questions to lead students toward correct ideas and applications. To effectively use questions for either purpose, tutors must employ good listening skills. Questions may be classified as closed-ended or open-ended. Both types of questions are useful in tutoring, but they elicit different kinds of responses. Closed-ended questions are those which may be answered with only a word or a phrase. Tutors should avoid asking a question in a closed-ended form when they want students to elaborate. Open-ended questions generally require more thought and more words to answer, and they are more useful in getting students to verbalize their ideas.
So here it's telling you why this one couldn't react, and what is it telling you?
It's there are no benzylic hydrogens. So I guess if the C, that the benzylic carbon, if it's not connected to any hydrogens, it can't go through that reaction.
Right.
So, how would you start?
Well, you get the molarity, or the number of moles of the H3. Would be helpful.
Here, Katie probes her students' reasoning with an open-ended question.
Okay, why is it there that you are assuming that all of your copper sulfate is being converted to your new product? What tipped you off?
Because the KF's real high.
Right.
Okay. That's pretty much essentially the way it's going to be for all like complex ions, right?
Right.
Problems. I just have to
They're
make sure I know
formed
what a
in-
complex ion problem.
Right. And just always remember that it's a metal surrounded by.
And never deal with KF
Right.
as well.
An open-ended question may be used in combination with a closed-ended question, as seen here.
Right. So which one here is your limiting reagent?
I don't know. Let's see. And they give you this one in molarity already.
Mm-hmm.
That one's going to be limiting reagent.
Exactly. That's right.
So,
And how could you tell that?
because it's a smaller number.
Good.
All right.
Good, open-ended questions often result in the student asking questions back to the tutor. On such occasions, the tutor learns more about what the student does and does not know.
How do you think you're going to start?
Okay, I figure if I have, they want above the x direction. Okay, would I need to find the velocity in the x and the y? Break it up?
Let's see some more examples of open-ended questions.
What are you working on?
On a report on a research article on memory and cognition that I have to do for my psychology class. And this is what it looks like. I wrote it, and as I told you before, it's like hard as heck to understand, so I think pretty much I covered what I wanted to say.
And we could put it in vector form by doing what? How would we put this parameterization into vector form?
It's just like 2 sine d theta.
Right, and then you'd add them all up.
Okay, since your x is in your exponent, what do you have to do in order to solve for x?
Why is that one? Why did you subtract that one?
Compute f to the negative 1 of 2. Tell me in words what that's saying.
Plug 2 in where the x is.
Of what?
Negative 1.
Tutors often use questions that tap into different levels of knowledge as classified by Bloom's taxonomy, particularly at the memory, comprehension, and application levels. Comprehension and application questions are generally open-ended because students usually will have to think and speak at length to explain concepts and how they are applied. On the other hand, memory or recall questions are usually closed-ended. Memory level questions are used by tutors to see if the student knows the details needed to form larger concepts and work problems. Let's see some examples.
What's the acceleration due to gravity?
Negative 9.8.
Okay.
What's the definition of a Lewis acid?
Something that has the ability to accept electrons.
Right.
Okay, what does I stand for?
No clue. Oh, -1.
The square
No,
root.
the square root of
Square root of -1.
Enviar
To
un
send.
paquete. No sé. Firmar.
to and
Firmar su nombre.
to sign.
Sí. Buzón. Si tú tienes una carta, ¿dónde probaste? Pare.
Mailbox.
A comprehension level question requires the student to explain a concept or form a short reply that demonstrates comprehension of the concept.
The energy input is required to break chemical bonds. What does that mean?
Okay. Energy input. What would you think that would mean?
Your work.
Right.
Okay.
What is this work going to do?
It's going to break the bonds.
So what does it mean if something is oxidized?
Means it gains an electron.
Observe Marcia's reaction when her student has difficulty with a question phrased at the comprehension level. After waiting and observing the student, Marcia rephrases the question at the memory level.
I plus 8.71J
Now what is that?
over. This is the velocity when it's coming to stop.
Okay. If you have a final minus original, it's a
Change.
right. So you want to say that's delta V.
Okay.
Right.
So the change in velocity is this much.
Mm-hmm.
Let's look at some other examples of comprehension level questions.
But what happened to the nitrogen in going from NO3 to NO?
It lost electrons. No, it gained. Do you still?
Okay, so
Alright, so is O just -2?
oh, isn't it still -2?
All right, and this has to be neutral, so this is going to be 2.
Right.
All right.
So if it went from plus
5
5 to plus 2, what happened to it?
It gained electrons.
Right, exactly.
Okay, they were individually studied. What does that mean?
Well, I mean, it was, every time the experiment was going on, they were alone in their structure, and it's not a big group thing.
I mean, even looking at the answer that they give there, what difference did the triple bond make?
It's gonna have 2 double bonds on it. So this one will stay exactly where it is. This one will go here, and then this one will go here, and this one will.
Yep.
Okay. What is the domain? What is the range? What's like a definition? Doesn't have to be the word for word book definition, but what is that?
The domain is what x equals.
Mm-hmm.
The range is what y equals.
Right.
An application level question requires the student to demonstrate the correct use of a concept or solution method in a problem situation.
And you want to find out where that line crosses the x-axis. How would you do that?
Solve for x.
Yeah. So if you want to find out in this equation, like where it crosses the x-axis, how would you do that?
Just solve for x again.
Yeah.
But it says there's more than one 0, so there's more than one answer for x.
Mm-hmm.
Just set it equals 0.
Yeah.
What other form can you change it to that would make it easier to solve for x?
You can say x to the 5th equals e5.
Right.
What would you think would come into play if we had, say, a tert-butyl group here?
The sterics effects. So this, if it was sticking up, it would be harder to get to because this is also sticking up, so it would need to be sticking down.
Yep.
So this would be the major.
Mm-hmm.
This would be the minor.
What would have to happen for those 2 carbons to form a double bond?
But if we lose the hydrogen?
Say if you wanted to find out how much was left, how much copper was left, how would you go about doing that?
You would subtract the initial
Right.
from the equilibrium.
Good.
All right.
That's exactly it.
Questions can be used to lead students to the correct concept. This technique, called Socratic questioning, is preferable to lecturing because it builds on the student's own ideas.
Okay. Well, what's the difference between this and, say, this one?
It has the double bond, the alternate double bonds. So,
So why can't it add here?
because it's already got 4 bonds to it, so it's
Right.
got to add over here.
What does it tell you?
It doesn't work.
Right. So what's your other method for doing?
Quadratic.
Yeah.
So I'll just plug this into the quadratic equation.
Mm-hmm.
So if copper 2 plus is gaining 2 electrons, what's happening to it?
It's being reduced.
Right. So which is the oxidizing agent and which is the reduction agent?
This is the oxidizing agent, and this is the reduction agent.
Good.
It's got some strange stuff.
Okay, you're right. It's a problem with the verb. Tell me about the verb. When is this taking place?
In the past?
Okay, in the past. Is it something that's continuing, started in the past and continues, or something that took place one specific time? It's
one
done.
specific time, yeah.
Okay, so what verb form do you want there?
Has.
What would has mean?
I don't know. I'm still like confused on that part. It would be has, have, had proposed. Wouldn't it be had?
You're guessing.
I know.
Tell me why.
Would it be
Read it. In 1993, Tanaka and Farah.
proposed? Proposed would be fine. No thing. Propose a holistic approach, and no has, had, or whatnot.
Okay, why not?
Because it's done, and they have finished the process.
Tutors use questions both for diagnosis and teaching. Open-ended questions are generally better than closed-ended questions in getting students to verbalize their ideas. Tutors can use Bloom's taxonomy to help them ask questions at the appropriate cognitive levels. Good tutors often use Socratic questioning to lead students to the correct ideas. When tutors use Socratic questioning, students learn that they possess the knowledge needed to find their own answers.